So continuing on, now we're looking at loops. So loops are one of also the key constructs in sort of programming. And so if you've done other languages, not necessarily just C, you're probably very familiar with the concept of loops. They're very similar in most languages and use the same sort of keywords. So the key concept of them is that they allow for some condition to instrument the repeated execution of some block of code, right? So you can see here, some block of code can be executed several times. And so one thing that makes it like powerful, but for instance, for some sort of critical embedded systems makes it hard to analyze, is that it allows for complex execution paths that can also dynamically change. Like if you're reading in, it's like a network packet, its length might not be fixed all the time, and so you can use sort of like loops to process it, but the amount of times the loop executes is not always necessarily known, right? So there are really three types of loops that are offered in C, and these are generally offered in like most languages, with the sort of exception of the do while, which is generally actually not used that much. I mean, in my life, I've probably used it only a couple of times, really. So they come down to mostly like basically these two, like a while and a do while are pretty much the same. So a while loop just means that there's some condition that's tested every iteration, and the loop is just executed until that condition is no longer met, right? So it just continuously executes. A perfect example is usually in a lot of embedded systems, you'll have a main function, and inside the main function, all of your code goes inside of a while one loop, which basically never ends, because an embedded system generally does one function and just does it over and over and over and over and over until it's unplugged from the power, right? So that's quite simple. A while loop just goes around until the condition is false. A for loop is the same idea, but the condition is an integer counting value, and it has a bound. So you can say, and by doing so, you're essentially instrumenting the execution of the loop a certain amount of times, right? Now the do while is the same as a while loop, but essentially the condition is, hold on, exactly. So for instance, a do while would be that the entrance point to this diagram would be here, in that you run the code and then check the condition to go again. And so what it means is that the code body will always run at least once, because you'll run the code, check to do it again. Instead of check to do the code and do the code and then check to do it again, you first do it and then you check. So looking at some more in detail examples, the while loop here, we can see this is a while one. So this is just going to sort of like run forever. And this will just increment from the foo++. We can see here, this is incrementing foo's value. This will just keep printing. So I've only printed the first four, but this will just keep going. Like this won't ever stop. And so here we can see like a little flow chart of it, of what's happening. Essentially, it comes into the condition. If the condition is true, and do the block, and it will just keep running in this until the condition is false, and then you continue with your code execution. So it's really quite simple. You have to be careful when you're writing code that you don't write while loops that you get stuck in. This can be a problem. And a lot of people actually do while one loops, and then you can also use, for instance, the break statement, which we'll come to in a little bit, to exit the loop, right? So then looking at the do while in comparison, it's almost the same. So we can see that here we have the while at the beginning, and here we sort of have like do this and then while this. And so this, you can always sort of remember, is evaluated at the end of the code instead of at the beginning of the code. And so the flow looks sort of like, come in, do the code block, check the condition. So in the while loop, we do check the condition, do the code block, and here it's just the inverse, right? And so what I'm doing here is essentially, I'll say, this example, foo is equal to 0, and I'll say, hey, do printf while foo is greater than 1. So obviously this condition here is never going to be met because foo is 0. Here it gets incremented to 1, but it's never going to be greater than 1. So what happens is it comes in, it runs printf, it increments foo. So it's printing the 0 and incrementing foo, but when this check is run, foo has a value of 1, and therefore it's not greater than 1, so the while loop actually doesn't start. But here we can see it's a pretty explicit example of when it runs at least once, even though this condition was never met, it's run once. So the for loop. Now this is probably one of the most common loops that you'll use, and is very powerful. So really what it is you're setting some sort of a range, like sort of an iteration that is used to count or to set how many times the loop should run. So we can see here in the brackets we're setting up sort of like an initialization of the loop's logic. This is the condition, and then this is the step, the update expression we can see here. So the test expression in this case is the I is less than 4. We have initialized it as I equals 0, and each update we're doing I++. So it means starting at 0, keep incrementing I each loop by 1 until I is no longer less than 4. So this will run this loop 4 times when I is 0, 1, 2, and 3, right? And this is exactly what we get. Same idea, we're using printf and we're doing foo++. So we're getting an incrementation of the foo variable, and we're running the loop 4 times, so we get the print 0, 1, 2, 3. And so this is very easy to follow here. But it's very important to note the order in which these happen. The initialization expression is done before, is run before the test expression for the first time. The loop body is then run before the update expression. So sometimes people get confused that the loop body happens after the update expression, but this is the case. It's very simple. And these don't have to be necessarily hard-coded. This, like for instance, this for here could be some dynamic variable that lets you run a loop a varying amount of times depending on some sort of an input. So they're very useful. So with loops, you sort of get to control statements. And now control statements are mostly used with loops. I mean, for instance, break we've seen was used with a switch statement, which was used to sort of leave the switch statement itself. But the most common use of them is for using with loops as control flow. So ways that you as a programmer can interrupt the flow, meaning how these little graphs work of the loop. So essentially we have the break and the continue. The goto is not so much used with loops. It can be used with loops, but I'll get to that in a second. The main two ones that are used with loops are the break and continue. And so the break statement, that's similar to like with a switch statement, it just leaves that scope. So it jumps up one level. So essentially if you're in a while loop, it'll leave that while loop. But if you're in a while loop and then inside that while loop is another while loop, if you run break, it'll just break that first while loop. You'd have to break. And so what the continue is very much the same thing, is that it also breaks the execution of the loop, like the loop's body. But the difference is that the break doesn't go back and evaluate the conditional logic again, whereas continue does. So break will leave the loop completely, but continue will say, okay, I will just skip back up to the conditional and evaluate again. If it still holds true, I'll then start executing the code body's code again. So continue, for instance, on a while loop would be if I had a continue in here, like if my code block, essentially at the beginning of my code block, if I had if some condition equals blah, 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 continue, and if that got evaluated, I'd essentially just skip this code block and go back to the condition. So that can be very useful. Goto itself is a more advanced and sort of rarely used sort of feature of C. I really like it. I think it's a really, really good way of doing great error handling, and you'll also see a lot if you go into, for instance, like programming in like Linux kernel. What it does really is you can set a label in your code, which I'll show in an example, and it just says if something, it'll just jump to executing that. So for instance, you could use it to leave a loop, but most commonly you'll use it to sort of do cleanup code, like if some error happens, jump to the cleanup code. And so it's also very powerful, but in, like I'd say, on average, very rarely used. So here we have some examples of continue and break. So for instance, continue here, if we're going through the example, foo is set to 0, and we're doing the same loop as we had before. We're going from I 0 up to 3, because it's going to be less than 4. Each time we're incrementing foo. And what I want to do here is I'm essentially skipping the print of I equals when on the third iteration. So 0, 1, and then 2, when I is equal to 2, I'm essentially skipping it by going continue. So what's going to happen? Foo is equal to 0. Oh, sorry, this is wrong. It should go foo is getting incremented. So then here it would print 1 instead of the 0. So these should all be 1 more than they are. Then it's going to go back again. I is going to be equal to 1. So this won't happen. Foo will get incremented to 2. And then it'll print 2. And then in the third loop, when I is equal to 2, it's going to increment it. So foo will be equal to 3. Then it's going to run here, and it's going to hit continue, and it's going to skip printing and go back up to the conditional, and then it's going to increment foo again. This won't hold, and then it'll print it again. So this should be 1, 2, and 4. I'll fix that up on my lecture notes. Similarly, we have break, and so what break does is essentially it's just looping, like this is while 1, meaning this is going to loop forever, and it's just saying, hey, I'm going to increment foo every iteration and print it, and when foo is equal to 3, I want to break, right? So it's going to print 0, so it should print 0, 1, 2, so actually I think this is also wrong. I'm doing really well today. So it's going to print here 0, and then it's going to increment foo. So then this won't happen. It's going to print 1, increment foo. And it's going to, okay, and this won't happen. It's going to print 2 and increment foo and then break. So this last expression should not be there. I will also fix this one up. So I think now I'm going to move on to functions, but firstly I'll run through an example of using control statements.